It's just going to be the I'm going to take out this, and it's just this rotation here. And we actually want to, I think, convert. These sizes aren't going to be right, are they? Like, the size of this object is not going to be what we'd expect. Again, it's going to be this convert texture space to world space. So we're basically going to take like a vector 2. Yeah, we're actually going to have like f vector, let's do like size vec, and that's going to be converting collision object size. Yeah, it's just going to be something like this. Oh, what's lagging behind? The box, or the trace there was not lagging behind. It was just showing up because I was moving and some of those things. It wasn't lagging behind. It was just it was in the right spot, which was good. It was just the wrong extents. And again, we got the wrong extents here. But let's double check real quick. Let's pop open FatSack and take a look at this collision. Like, the height is a lot larger. That's it. Okay, yeah. I'm just looking at some of the math, and the math is confusing me. And the reason is some of it was going positive in the z-axis for the offset. And the reason it was going positive in the z-axis for the offset was because the center of the box for this guy is actually like positive. It's above this thing in the z, so I was like, what the hell? Because this box is bigger, and I was like, there's no way that can be right. And it looks like it is. Anyway, so we need to print out the extents of the box and see what's going on with that. And we also need to undo kind of our work here. We're gonna have to rotate the shape to this thing. Is that what we're gonna have to do? So let's see. The extents vector before rotation is size vec. And then if we rotated it, extents vector after rotation is such. I would or not swap this. It's all. We're getting close. We're not dealing with just a couple simple transformations. The paper 2D stuff is mapping stuff into texture coordinates which are separate from. It's dealing with a completely different unit set than the rest of the world, so it's not something that's just a simple transform. There's not just a thing there. The extents after rotation. Why in the hell are the extents negative? Size is frickin' negative? Size is 151 and then 48. Afterwards, it's these two variables. And then after we rotate them, it's very fat, not very tall. And the size should have been yeah, it's supposed to be very fat and it's supposed to be not very tall. That's what it's supposed to be, but why is it so incredibly fat? the size is not, we're not transforming it properly. It's supposed to be, is it world space delta the texture space, or the difference? It's like a texture space delta. I mean, I guess it's convert texture space to world space, but the problem is our size needs to be a little bit different. If we take our position and we add our size to it, we'll get the other side of the box. So if we transform that point and then subtract so if you do position plus size, we transform that, and then we subtract those two. It's just basically the extents are going to be 0.5 times the upper left minus the right. So I need to do math on this. So it's position plus the size, and that's going to give us the box max right there. And our f vector size vec is going to equal the box max minus pos offset times 0.5. And that's half extents. This make sphere takes the sphere radius, which will be, it should be half of it, so we'll see. That should do it. Yeah, it was basically like that. The math is getting all sorts of jacked up by the projections onto these axes that Paper 2D is working in, and it's also got this like pixels per Unreal unit, which is baked into the sprite itself, and doing some other stuff. So like, it's working in arbitrary axes, which we could try to simulate and like hack in there, but it's just best to use their math functions, I think. And that's what we should be doing. Shouldn't be doing anything else. So the extents vector after rotation is 75, negative 80, and 75, negative 24. So the only difference is that we should be taking the absolute value of all these components for this thing. So it's like size vec x is absolute value of blah blah blah. Alright, so the extent vector after rotation is 0, 75, 80, and 0, 75, 24, which I believe is exactly what should be. And yeah, you can see our two little boxes there are absolutely correct. Alright, so we've got our can we stand in this location function working properly. And it's going to say no. And it's failing immediately. So here it would say, yes, you can stand. All that. And here we cannot. Cannot stand. Can't stand. We cannot play our air rising. We cannot play. We can. We can. We can. We cannot. Can. Alright. So that is our checks. It looks like there's a little bit of an issue there with one of these things, which I need to take a look at. Just inside of our let's see. Our entity is false, get entity animation data. Anims are fine, get for set. Okay, so the reason I was wondering why when I was moving the character and then I hit the B button, it was just returning false without actually checking to see if anything was messed up. That's because it was actually trying to check against an animation that didn't exist. Which is good. It means things are working properly. So we've got our can you play an animation working actually properly. Cool. So we got it. We got that at least. Let's take a short look at if we can improve any of these things real quick. And just like not... We can just do a few little optimizations. Or at least a few little code cleanups. Yeah, it looks fine. And we can just yeah, we collided on frame blah. We already got that, so we just return false. We are good to go. I'm just thinking about stuff, just trying to reason if there's anything else that we're missing that I need to really take a look at. Basically going over in my mind if we've got this character, and because we've introduced this thing where we're not always in the same physics state all the time, if there's any issues with like the can play animation is going to take what would be an ideal state. And it's really there to just to make sure that things can work. So if we're in a wrong physics state, it could be a little bit in the wrong place. But the only time we should ever get into that bad physics state should be as if we did something real weird. But I think we got it pretty good. Like there's nothing that's jumping out as awful. So yeah, that should be okay. So the next thing on our list is creating multiple physics objects in the same world and making sure that we can collide with them correctly while moving around. So probably a good time to take a break right here. So we've got our checks working out properly. So get animations for set and type. Get animation set for velocity. Alright, so we'll get our animation set for velocity. And what we want to do is we don't want to just call this off here. We actually want to get our animation data. So you have like switch. Yeah, it's going to be like while set does not equal the stationary set. Well, it's not AS stationary, it's... Looks like we have to go add one. Is this animation constants? Yeah. We really need a none here or something else. So I guess a do while loop. And basically what we want to do is we want to call like get anims for set and type. And this play animation is basically like we want to get an animation for a set and type, so we actually want to make another thing here, which is going to return an F animation wrapper. Because we want this thing to grab the correct animation that we want. We're going to want to do a animation wrapper, get animation for type. Get animation for type and set. Basically, our animation dictionary is broken up by speeds and all that stuff. So, like, if there is a dash animation or moving at our dash speed, we should actually get our animation. We should not be returning. We should be returning a pointer, not a reference, because we may return null. So it should be something along these lines where we're going to return our, so it's like anim data, get animations for type and set. So if anims.num is greater than 0, then we're just going to return the address of anims sub 0. Otherwise, set, we're going to switch on set and case. This thing is all sorts of angry at me right now. Yeah, this is why it's angry. Alright, case dash. So if it's walk, we're gonna say set is stationary. It's basically like it's gonna walk down the list. It's gonna try at the most the fastest one, and it's gonna walk backwards all the way. And if we can return something, we will. Otherwise, we're gonna return one pointer. To hell with it, we're just doing a while true loop. So if we get to the bottom, we're done. Type and set should be specific. get animation for type, the first thing that you do, it's actually going to call get animation for type and set. But first we need to discover our set, so we need to call get animation set for velocity. There, that's all we need to do there. And can play animation by type should call get animation for type and set. And it should call get animation set for velocity first. And then we'll return the pointer to the F animation wrapper. So if the animation is null, we just return false. Otherwise, we do can play animation and pass the star wrapper. And then can play animation takes the reference to the anim wrapper. Do we actually change the anim wrapper at all? No. So we could take a const reference to an anim wrapper. So why don't we just do that? Is this thing going to complain about not knowing what the hell an animation wrapper is? And let's see exactly what that is. It's a struct. Alright, so we're just going to say struct. Right here. Yeah, that's what I was bitching about. So let's compile it, make sure it compiles, and we'll throw all that stuff way down in the file so we never have to look at it ever again. Ever again. Yeah, we don't need that. Alright, so we can go ahead and take all this stuff and put it a little bit lower. Because I like to have the update stuff for ticking and all the rest. I like to have that kind of next to each other and kind of the first thing you get to in the file, and then all like the utilities that do crap to be farther below, so it's a little bit more organized. So you're like, okay, and then what does it do? And then like these are all the update methods, and then after all the update methods, we've got like all the things that do things like calculating our bounds and screwing around with stuff, seeing if we can do things, all of that. Cool. Looks like that's all working. Extra crash bug. So I think I can take a short break here. Maybe like a 5-minute or so, and I'm gonna come back, and when we come back we're going to try to get multiple physics objects roaming around the scene. So we're gonna get Fat Sack, like a kind of an AI Fat Sack in there. And the question is, how smart do we want to make him? Probably just give him some basic AI, something like we could just code out some really crappy stuff for him. So I think we do want like an agent that's actually going to go do something here. We don't want him to do like a whole bunch of wall jumping or something, but we do want him to like crawl around a bit and kind of stay within the confines of an area. And we do want him to try to jump up onto platforms. So we might just throw some really shitty AI in there and see what he can do. Genius, yeah. Smart Sack? I don't think so. This is going to be a real dumb Fat Sack. It's going to be a real dumb Fat Sack. But yeah, I think we'll actually do that. So let's actually not do create multiple physics objects just yet. Let's create basic Fat Sack roaming AI that is super shitty. And then once we have that in there, then we'll do the movement. And those little dudes will help us test out the movement, because we need them crawling around. So when we jump on them and crap like that, we see all the stuff that's totally freaking busted with our collision, that sort of stuff. So we're gonna take a short break here. Thanks for sticking around. So you think we're ready to go? Think we're ready to make Fat Sack do Fat Sack things? We're gonna make it really awful. I forgot my water. I'll be right back. We're gonna make a really awful AI for Fat Sack and throw a couple of them in here. So let me know your suggestions for what Fat Sack should do. We're not going to be playing his animation or anything, so having him dig in the dirt, probably I'm not going to go do that. But if people whine and complain enough, I might. So get your suggestions in now. So let's do it. Let's make the dumbest of dumb dummies for Fat Sack, and let's make it real quick. Hop over small obstacles while running away. Well, we need them. We need them to. You know, we want to interact with them. We want to run up to them and like jump on them and do all those things. So I'm not gonna have them like run away and hide and some other stuff like that. It needs to be useful for our debugging here. So this is going to be Fat Sack not interacting with like other Fat Sacks or anything. It's going to be Fat Sack doing something, and like randomly hopping around would work. Things like that are pretty simple. But I'm not going to be like, they're not going to have swarm intelligence. You know, we're making a debug character here to help us out while we're messing around with things. I need another movement type, so I think that's in data over here. Where the hell did I put this? It's in here. Is it game data? I'm just like, Jesus Christ! I know it's here. So let's see, where are we? What else are we referencing this thing? Maybe I have a debug character. He'll just run away and fall off the world and then die. Entity movement controller component. Yeah, so we really don't have a whole heck of a lot in here. So we're kind of hacking a few things in here just to get our... Because we don't have like AI and the rest done yet for this. So this is entity movement controller component. So what we need to do is actually switch off of the movement controller type. And then we'll create our movement controller object. Unfatsack, fatsack. It's still going to be fatsack, so it's about... That's still going to be there. So this is going to be get movement object, get entity, and movement. I think one of our guys has... Is it any proxy data has our movement data on it? So it should be U movement data. Let him try to get to the highest point. Well, for him to get to the highest point, he'd have to like know about the highest points and all that sort of stuff. He does not. Alright, so we have a movement type. So this is the type of movement our character moves with, which is like locomotion and all that stuff. We need a movement controller. So we need to go to the entity constants.h, I believe. And we're looking for bipedal. Yeah, so it's like movement controller type. Do we have anything in here that does anything like this? Is it inside of the entity data? Any type, any group? No, it's not in there. I swear it was on the movement controller component itself. No, it's not. Is it on the movement object? No. Cannot be. Dashkin. Was it in the entity data itself? No, we haven't written any of that, right? Like we have no AI right here. We don't have any way to discover stuff. We could like cast some rays or something, right, to see if like there's something in front of them. You know, we can do some of those sweeps and some of those other things that we've been working on over the past week, right? We could try some of those out, but not much else. So I need to figure out where the hell the movement controller is actually set. So I need to compile it real quick and then run what we're doing. So yeah, we could do some basic site stuff. Like you could maybe sit there and we could cast some rays, kind of. Kind of like if Fatsag is here and there's a platform here, right? We could like we could kind of cast some rays, kind of like this, and he could see, oh, there's like a platform I could get to right here, and there's like clear line of sight here, so maybe I should back up to try to back up to this location, and then I'll just jump, and then it'll go and maybe land on it, right? We could do that because it's just some ray casts and like run to the left and blah, right? That's not too crazy. But we don't have like, you know, get all the fat sacks in the sea and try to run towards each other. I mean, we could. You just gotta bitch at me enough to convince me that it's worth my time. Alright, so that's just animation stuff. The FATSAC proxy has entity type and group. I see a movement controller. And FATSAC movement has nothing on it. So the movement controller should actually... so the movement controller should have a thing on it. So what is the movement controller? It's on the proxy and it's called movement controller. So let's go take a look at that real quick. It's a movement object. So where's the movement object? It's just a movement object pointer?